Welcome to our deep dive into the life of Max Planck. You know, I have to admit, the more I dig into this material, the more I'm struck by how one person could revolutionize our understanding of the universe. Like, we're going to explore not just what he discovered, but the path he took, a path that led him to challenge the very foundations of physics as he knew it.
It really is a fascinating journey. Planck's story isn't just about equations and discoveries. It's about the courage to question assumptions, to grapple with the unknown, and ultimately to embrace ideas that seemed radical at the time.
Yeah, let's start with his background. It sounds like Planck was practically destined for a life of the mind. I mean, both his grandfathers were professors, his father was a professor. Did they ever even consider letting the poor guy play outside?
Well, it's true. He came from a long line of academics, and that upbringing certainly fostered his intellectual curiosity and rigorous approach to knowledge. But he wasn't just a bookworm, though. He was a talented musician, playing piano, organ, cello. He even composed his own songs and operas.
Wow, a true Renaissance man. Though I have to admit, I'm kind of relieved he chose physics over a career in music. The Planck Concerto in E minor doesn't quite have the same ring to it as, say, quantum theory.
Perhaps not. But his early musical talents speak to the breadth of his intellect and his appreciation for beauty and harmony, qualities that would later manifest in his scientific work as well.
Yeah.
And speaking of his scientific journey, his education put him in contact with some of the leading physicists of the day, people like Hermann von Helmholtz and Gustav Kirchhoff.
Oh, wow. Those are names that even I, with my very limited physics knowledge, recognize. I bet studying under those giants really shaped his thinking.
Absolutely. These mentors provided him with a solid grounding in classical physics, the prevailing view at the time. It's ironic, though, that one of his professors actually discouraged him from pursuing theoretical physics.
Real?
He told Planck the field was practically complete, with only minor details left to iron out.
Oh, to be a fly on the wall when that professor later learned about Planck's groundbreaking work. Talk about a misprediction.
It just goes to show you that science is full of surprises. And Planck's early work really exemplifies that. He became deeply fascinated by the concept of entropy. That whole measure of disorder idea.
Okay, confession time. I've heard the term entropy thrown around, but to be honest, I'm not sure I fully grasp it.
Well, think of it this way. Imagine a perfectly ordered room. Everything in its place. Not a speck of dust. Now imagine that same room after a wild party. Things scattered everywhere. Complete chaos. Entropy is a way of quantifying that transition from order to disorder.
That makes more sense. So Planck was diving into this concept of entropy, meticulously clarifying and building upon the work of earlier scientists like Rudolf Clausius. But there's a twist, right?
Exactly. You see, while Planck was a master of thermodynamics, he was initially skeptical of the idea of atoms. He preferred a more phenomenological approach, focusing on observable phenomena rather than speculating about unseen particles. This is fascinating because it highlights how scientists can arrive at similar conclusions about the universe, even when their underlying assumptions differ.
So he was figuring out the math of how energy and entropy worked without necessarily needing to picture tiny atoms bouncing around. That's pretty impressive. But I know this story takes a dramatic turn. There's a reason why we're talking about Max Planck and not, say, Rudolf Clausius, right? What happened that catapulted him into the realm of scientific legends?
To understand that, we need to set the stage. It's the late 19th century, and physicists are grappling with a puzzle known as the black body problem. Imagine a furnace, the kind used to melt metals.
Okay, got it. Hot, fiery, and probably best admired from a safe distance.
Exactly. Now imagine this furnace as a perfect absorber and emitter of radiation. This idealized object is what physicists call a black body. The problem was, existing theories couldn't explain how the intensity and color of the light emitted by this black body changed with its temperature. They had equations that worked for either high frequencies or low frequencies, but nothing that explained the whole spectrum. It was a major roadblock in our understanding of how light and matter interact.
So there was this gaping hole in our knowledge, and physicists were scrambling for answers. Enter Max Planck, right?
Enter Max Planck, indeed. And his first attempt to tackle this problem, building upon his earlier work on entropy, actually failed. Can you imagine the frustration? Years of meticulous research hitting a dead end?
Ouch. That's got to be a blow to the scientific ego. But knowing what we know about Planck's eventual success, I'm guessing he didn't just throw in the towel.
Absolutely not. This setback, this failure, is precisely what led to his most revolutionary breakthrough. It's what forced him to consider an idea so radical, so counterintuitive, that it would shake the very foundations of physics.
Okay, I'm all ears. What was this radical idea that Planck came up with? The one that turned the physics world upside down.
Well, in a moment of desperation, what Planck himself called an act of despair, he proposed that energy, instead of flowing smoothly and continuously, actually exists in discrete packets, like tiny bundles of energy. He called these packets quanta.
Hold on, so instead of energy being like a dimmer switch where you can adjust the brightness gradually, it's more like a light switch that's either on or off.
That's a great analogy. It was a complete departure from the prevailing view of physics at the time. Imagine trying to convince everyone that water doesn't flow smoothly from a pitcher but comes out in perfectly measured droplets. That's the kind of upheaval Planck was proposing.
Oh, wow. I can only imagine the resistance he must have faced. But this idea of energy quanta matter, didn't that become, well, kind of a big deal?
Kind of a big deal is an understatement. This was the birth of quantum mechanics. Planck's act of despair led to a revolution in our understanding of the universe at its most fundamental level. And at the heart of this revolution is a simple, elegant equation, E.
Okay, time for a quick physics lesson. E stands for energy, right? But what about the rest of those symbols?
So E represents the frequency of the radiation, essentially the color of the light, and H is Planck's constant, a tiny but incredibly important number that governs the size of these energy packets. It sets the fundamental scale for the quantum world.
So this tiny constant, this H, is kind of like the secret code that unlocks the mysteries of the subatomic world.
Exactly. It's like a universal exchange rate between energy and frequency. And without it, our entire understanding of how the universe works at the smallest scales would be completely different.
Wow. It's amazing to think that such a small constant could have such enormous implications. But I know Planck didn't work in isolation. There were other scientific giants on the scene at the time, like Albert Einstein. How did their paths intersect?
Planck and Einstein had a complex and fascinating relationship. They both revolutionized physics in their own ways, but they also had very different philosophical approaches to their work. What's remarkable is that Einstein was one of the first to truly grasp the significance of Planck's quantum theory. He'd even used it to explain the photoelectric effect, which earned him his own Nobel Prize in 1921.
So Planck's work actually paved the way for Einstein's own breakthroughs. That's quite a legacy. But you mentioned they had different approaches. What were those differences?
Well, Einstein fully embraced the probabilistic nature of quantum mechanics. He accepted that at the subatomic level, we can only predict the likelihood of certain outcomes. Planck, on the other hand, remained deeply attached to the deterministic worldview of classical physics. He hoped that a more predictable explanation for the quantum world might eventually emerge.
So even geniuses can disagree. It makes me feel a little better about my own struggles with physics. But their disagreements must have led to some pretty interesting conversations. Didn't they share a love of music too?
They did. Both were accomplished musicians. Planck was a gifted pianist, and Einstein was a devoted violinist. It's fascinating to think about these two titans of physics who challenged each other intellectually, also bonding over their shared love of music.
Yeah, I'm picturing them having these late-night jam sessions, debating the nature of reality in between sonatas. It must have been quite a scene.
I imagine their conversations were quite lively, both musically and scientifically. But as with any life, Planck's story wasn't all scientific triumphs and intellectual sparring. He also endured his share of personal tragedies.
Yes. I read about the loss of his first wife and 3 children. That must have been incredibly difficult for him to bear. How did he cope with such immense sorrow?
Well, he was a man of great resilience and stoicism. He faced these losses with a quiet dignity and continued to immerse himself in his work. His second wife, Marga, whom he married in 1913, provided companionship and support during those difficult times.
Yeah. It's a reminder that even the most brilliant minds are still human, still vulnerable to the same sorrows and joys as the rest of us.
Absolutely. And Planck's life took another dramatic turn with the rise of the Nazi regime in Germany. This period presented him with profound moral dilemmas. He was a patriot and a man of tradition, yet he was deeply opposed to the Nazi ideology and its persecution of Jewish scientists.
So he was caught between his loyalty to his country and his conscience. How did he navigate such a difficult situation?
It was a delicate balancing act. He never publicly denounced the Nazi regime, which has drawn criticism from some historians. However, he did work quietly behind the scenes to protect Jewish colleagues and resist the worst excesses of the Nazi ideology. For example, he continued to teach and promote the work of Albert Einstein, even though Einstein's theories were condemned as Jewish physics by the Nazis.
It must have taken a lot of courage to stand up for scientific truth in the face of such a repressive regime.
It did. And he paid a price for his defiance. The Nazis forced him to resign from several prestigious positions, and his beloved Kaiser Wilhelm Society was effectively brought under their control.
Oh, It's tragic that such a brilliant and principled man had to endure those final years under the shadow of such darkness. What happened after the war? Did he get to see the world embrace his discoveries and the field of quantum mechanics flourish?
Sadly, he didn't live to see the full extent of the quantum revolution. He passed away in 1947, but in his final years he witnessed the rebuilding of German science and the growing recognition of his own contributions to the field.
I imagine that brought him some solace, knowing that his work had laid the foundation for such a transformative field of study.
I'm sure it did. And his legacy continues to inspire generations of scientists and thinkers around the world. His story is a testament to the power of human curiosity, the importance of challenging assumptions, and the enduring impact of one person's willingness to embrace radical ideas.
Wow, what a journey we've been on with Max Planck. From his early fascination with entropy to his groundbreaking work on quantum mechanics, his story is full of twists and turns. But one thing that really struck me is how his life was so intertwined with the tumultuous history of Germany in the early 20th century.
You're absolutely right. And as we delve further into his later years, we see how those historical events, particularly the rise of the Nazi regime, presented him with some truly difficult choices. We touched on this briefly before, but it's worth exploring a bit deeper.
Yeah, I'm curious to hear more about how he navigated those challenges. He never openly denounced the Nazis, which has been a source of debate among historians. But you mentioned he worked behind the scenes to protect his colleagues and resist their ideology. Can you give some specific examples of that?
Certainly. One of the most striking examples is his unwavering support for Albert Einstein. Einstein, as you know, was Jewish, and his theories were condemned by the Nazis as Jewish physics. Planck could have easily distanced himself from Einstein to protect his own position, but he refused to do so. He continued to praise Einstein's work publicly and even arranged for him to give lectures, much to the chagrin of the Nazi authorities.
That took a lot of guts, especially considering the climate of fear and repression that existed in Germany at that time.
It did. And it wasn't just about Einstein. Planck used his influence to try to shield other Jewish scientists from persecution. He wrote letters of recommendation, helped them find positions abroad, and even intervened directly with Nazi officials on their behalf. Of course, his efforts weren't always successful, but he never gave up trying to protect his colleagues and preserve the integrity of German science.
Yeah, it's a powerful reminder that even in the darkest of times, individuals can still make a difference through acts of courage and compassion. But I know that Planck faced consequences for his defiance. Can you tell me more about that?
Well, as the Nazi grip on German society tightened, Planck found himself increasingly marginalized. He was forced to resign from several prominent positions, including his presidency of the prestigious Kaiser Wilhelm Society. He was also subjected to surveillance and harassment by the Nazi authorities.
It's heartbreaking to think that a man who'd contributed so much to science and to his country was treated this way by the very regime that claimed to represent Germany's best interest.
It's a stark reminder that scientific progress doesn't happen in a vacuum. It's always influenced by the social and political forces of the time. And in Planck's case, those forces were incredibly destructive.
So how did Planck spend his final years? Was he able to find any solace or meaning amidst the chaos and destruction of World War II?
The war years were undoubtedly difficult for Planck. He lost his home in Berlin to Allied bombing raids, and his son Erwin was executed by the Nazis for his involvement in the plot to assassinate Hitler. It was a period of profound loss and grief.
It's hard to imagine the strength it must have taken to endure such personal tragedies on top of the larger societal upheaval.
Planck was a man of remarkable resilience, and even in his late 70s and early 80s, he continued to lecture, write, and engage in scientific discourse. He saw the pursuit of knowledge as a source of hope and meaning, even in the darkest of times.
That's incredibly inspiring.
Yeah.
So what ultimately became of Max Planck? Did he live to see Germany's defeat and the dawn of a new era?
Planck passed away in 1947 at the age of 89, just 2 years after the war ended. He didn't live to see the full flowering of quantum mechanics, but he witnessed the beginnings of its transformative impact on science and technology. And in his final years, he was honored and celebrated for his groundbreaking contributions to physics.
It's fitting that he received recognition for his work, though I'm sure the true reward for him was the joy of discovery itself.
I think you're right. Planck was driven by a deep curiosity about the universe and a passion for understanding its fundamental laws. And in the process, he revolutionized our view of reality. His story is a testament to the power of human ingenuity, the importance of perseverance, and the enduring legacy of one man's willingness to challenge the status quo.
Well, we've reached the end of our deep dive into the life of Max Planck. It's been an incredible journey filled with fascinating insights and thought-provoking questions. What are some key takeaways you hope our listener will carry with them from this exploration?
Well, first and foremost, I think it's important to remember that Max Planck was more than just a brilliant physicist. He was a complex individual who navigated a tumultuous period in history with courage, integrity, and a deep commitment to scientific truth. His story reminds us that science is not just about equations and experiments. It's also about the people who drive those discoveries and the societal forces that shape their work.
That's an important point. We often focus on the scientific breakthroughs themselves, but it's crucial to remember the human stories behind those achievements.
Exactly. And I also hope our listener will appreciate the sheer audacity of Planck's discovery. His idea of quantized energy wasn't just a minor tweak to existing theories, it was a fundamental shift in our understanding of how the universe works. It was a leap into the unknown, and it opened up entirely new avenues of scientific exploration that continue to shape our world today.
And it all started with what he called an act of despair. It's amazing how sometimes our greatest breakthroughs come from our perceived failures.
It's a valuable lesson for all of us, whether we're scientists or not. Sometimes being willing to embrace the unknown, to question our assumptions, and to step outside of our comfort zones can lead to the most unexpected and rewarding discoveries.
Well said. And on that note, I think we can safely say that Max Planck's legacy will continue to inspire and challenge us for generations to come.
Absolutely. His story is a testament to the enduring power of human curiosity and the transformative potential of scientific inquiry.
Thank you for joining us on this deep dive into the life and work of Max Planck. We hope you've enjoyed the journey.
Until next time, keep exploring, keep questioning, and keep diving deep.